GeopByte.
Dear students, now let us discuss the previous year questions for the very small unit, that is thermal properties of matter. Okay, from this very small unit, one question can be expected for the NEET exam, that is the weightage of this particular small unit for the NEET exam. Okay, I hope all of you clearly understood all the theory concepts what we discussed for thermal properties of matter. Understood or not? Yes. Then let us take the very first question. Look at this question asking like this. Two rods, one made of copper and other made of steel of same length and same cross sectional area are joined together, given like this. There are two rods, one is copper and other one is steel. So given that length of the steel equal to length of the copper, and the area of cross section for steel equal to area of cross section for copper. But thermal conductivity of copper 385, thermal conductivity of copper is 385, whereas thermal conductivity of steel is, let that is Ks, equal to 50. Both are joules per second Kelvin meter. Okay, the free ends of copper and steel are held at 100 degrees centigrade and 0 degrees centigrade. That means temperature of copper, let that is Tc 100 degrees centigrade, and the temperature of steel, that is equal to 0 degrees centigrade respectively. The temperature at the junction is, what is the junction temperature? Temperature of junction, let that is T is how much? That is the question. Okay, once you join the copper and steel at different temperatures, the high temperature copper rod is losing the heat energy. Heat lost by the copper rod equal to heat gained by the steel rod. Finally, both are coming to thermal equilibrium at temperature T. Okay, for that we are deciding the T value from the basic formula of heat transfer. As you know, rate of heat transfer general formula delta Q by delta T, small t is for time, equal to K A into delta T, capital T for temperature, small t for time, right? Divided by divided by L, divided by L. Here, heat lost by the, right, heat lost by copper equal to heat gained by, listen carefully, heat gained by steel, because steel is available at low temperature. Heat lost by the copper, I can write del Q for copper, del Q by delta T. Let me write it clearly. That is del Q by delta T for copper equal to del Q by delta T, or delta Q by delta T for steel. So here it can be written as Kc into Ac into delta T for copper divided by length of the copper rod. It must be equal to thermal conductivity for the steel material into area of cross section of the steel rod into delta T for the steel rod divided by length of the steel rod. But it is clearly given that the length of the copper equal to length of the steel, and area of cross section for steel equal to area of cross section for copper. So these two fellows are cancelling, these two fellows are cancelling. Kc into delta T for copper, change in temperature of copper, equal to Ks into delta T for steel. Here, the copper temperature is dropping from its temperature, that is 100 degrees centigrade, to T. Therefore, Kc into Tc minus final temperature of the copper equal to Ks into temperature of the steel rod is increasing. Therefore, final temperature of the steel rod is more compared to its initial temperature. Okay. From that, I can write that. Kc how much it is given? Kc 385, Ks 50. 385. Here Tc 100 minus T equal to 50 minus T minus 0 degree centigrade. 385 divided by 50 into 100 minus T is equal to T minus 0. 50, right? Here it is 50 into, okay, 5, 10 times, 5, 7 times, 7, 7. It is 7.7 into 100 minus T is equal to T. 770 minus 7.70 equal to T. 770 equal to 7.7T plus T is equal to 8.270. Therefore, T equal to 770 divided by 8.7. You simplify this value for getting around 88.5 degrees centigrade. At that temperature, both are maintaining the thermal equilibrium. Look at the option. Option D is absolutely correct. Understood clearly? I am trying to explain the each and every point at your better understanding level. Okay. Similarly, let us take the another important problem. Look at this problem. Asking like this. A cup of coffee cools from 90 degrees centigrade to 80 degrees centigrade in T time, in T minutes, right? So for dropping the temperature from 90 degrees centigrade to 80 degrees centigrade from the coffee cup, the time required is T. Okay. When the room temperature is 20 degrees centigrade, let room temperature means surrounding temperature, room temperature, let it be TR, is given 20 degrees centigrade. The time taken by similar cup of coffee to cool from 80 degrees centigrade to 60 degrees centigrade at the room temperature same at 20 degrees centigrade. For the second case also room temperature remains same, but here the coffee cup is cooling from 80 degrees centigrade to 60 degrees centigrade. What is the time required? Let that time required is T dash. This T dash is how much? Got the meaning of question? It is given that the time T is the is the T minutes time is required for dropping the temperature of coffee cup from 90 degrees centigrade to 80 degrees centigrade, while the room temperature is 20 degrees centigrade. For the same room temperature, what will be the time required for dropping the same cup of coffee from 80 degrees centigrade to 60 degrees centigrade? Okay. For that, the relation between the you should know relation between the rate of change of temperature and thermal conductivity. As you know, rate of change in temperature, rate of change in temperature, delta T by delta small t, capital T for temperature, small t for time, equal to K into T minus T room temperature. T room temperature. But here K remains same because same cup of coffee. K is the thermal conductivity. Now delta T, right, for the first case, let this is the case 1, case 2. For the case 1, delta T means 90 minus 80. 90 minus 80 divided by time required is T equal to K into, here this T must be average temperature, T average, right? That is 90 plus 80 divided by 2 minus room temperature. Room temperature is given 20 degrees centigrade. It is 90 minus 80, 10 by T equal to K into 90 plus 80, 170 divided by 2, 85 minus 20, 20. So from this I can write that 10 by T equal to K into 65. Let us take another slide. 10 by T equal to 10 by T equal to K into 65. From this, the thermal conductivity K equal to 10 by 65 into T. 65 into T. Similarly, for the case 2, the temperature is dropping from 80 degrees centigrade to 60. 80 minus 60 by T, 80 minus 60 by T dash, here time is T dash, equal to K into 80 plus 60 divided by 2 minus room temperature is same, 20 degrees centigrade. Here it is 20 divided by T dash equal to K into 80 plus 60, 140 divided by 2, 70 minus 20. Here 20 by T dash is equal to K into 50. K into 50. From this K equal to 20 by 50 into T dash. 50 into T dash. Now let this is the relation number 3. Relation number 4. From 3 and 4. From relation number 3 and 4. Right? LHS are equal. You can equate the RHS. 10 by 65 T is equal to 20 by 50 into T dash. From this T dash equal to 20 into 65 into T by 50 into 10. 50 into 10. So T dash equal to here 10, 10 two times, 10 two times, 2, 25 times. So finally it is 65 by, let me write it clearly, T dash equal to, so T dash equal to 65 by, right, 25 into T. Here 5 times, 5 13 times. It is equal to 13 by 5T. So you got T dash equal to 13 by 5 into T. That is the answer. Look at the options. 13 by 5 into T. Option C is absolutely correct. Understood clearly?
GeopByte.